Or else we will wait for another 2 minutes so that the people will join. Okay, tell me what we discussed in the yesterday's class. Anybody? Have you understood the concepts what we have learned yesterday?
Yes, sir.
Okay, so yesterday we learned about a half adder, full adder we have learned, how we can derive an expression for the Boolean expression for the half adder. So for the half adder, it is nothing but A exclusive or, and for the carry, half adder sum A exclusive or B with B, and for the carry it is A into B. And for the full adder, so what is the sum expression? A exclusive or with B, exclusive with C, isn't it? And what about for the carry, full adder?
Sir, A bar BC plus A B bar C plus A B C bar plus ABC.
Oh, what is the simplified version of that, Pushkar?
Oh, sorry. BC plus AC plus AB, sir.
Yes, AB plus BC plus AC. Or else, see, it's better to remember like this. It is AB plus A exclusive with R with B multiplied with C. Okay, so if you remember like this means, then you can implement a full adder by using two half adder. Okay, so for the full adder, yes, it's correct. Carry is nothing but AB plus AC plus BC. But if you want to implement with the use of two half adder means, so you remember the carry expression in this manner also. That is nothing but AB plus A exclusive or with B into C. So if you remember this means, then you can able to implement or realize by using basic gates, by using logic gates, and by using a universal gate. Okay, so those are the very important concepts. So now we will move on to the next concept. See, now from now onwards the complex will become little bit means the concepts will become little bit complex and it will be tricky, so you need to grasp the thing as early as possible. Okay, everything can be understandable, but the thing is you need to put little bit extra efforts. Okay, so today we are going to learn one more important concept. So that important concepts we call it as a multiplexer. We call it as a multiplexer. Have you heard anywhere about these multiplexers? Have you heard anywhere this what you mean by multiplexers? Anyone?
Sir.
Yes, what do you mean by multiplexer? Anyone? Yes. Anyone? What do you mean by multiplexer? Hmm. Okay, just wait a minute. Okay, so basically, okay, anyone is know about this? What do you mean by multiplexer? Yes, anyone? Yes, Sarpita?
No, sir.
So
Yes, Naveen?
they are like switches which is used in different devices like uh, routers and other things.
Yes,
That
very
data
good.
links mostly in defense industries I have seen.
Yes, very good. Okay, so let us try to understand what you mean by multiplexer. Okay, so let us try to understand. So what you mean by multiplexer? So in order to understand the basic operation of the multiplexer, so let's consider we have four systems we have over here. Okay, one system means computers I am telling. So one system, two system, three system, and four system we have. Okay, so now these four systems they want to access a common one printer is there. Let's say you have a printer. Okay, so these are the all the devices. Okay, so the device 1, 2, 3, and 4. Now all these devices want to access the printer. So now simultaneously all the devices cannot have access on the printer. So what we can do is, so we should give any one device to access the printer. any one device we should give to access the printer. So that job sometimes or somewhat I can call it as a multiplexer. So you can see multiplexer will have a many inputs. Multiplexer will have a many inputs, but it produces only one output. It produces only one output. So somewhat we can represent or correlate the multiplexer in this manner. Okay, so now what I want to give access to this device one. So I want to give access for the input signal one is there. No, I want to give access to the printer one. So after sometimes I want to give access to the third computer to access this, and after sometimes I want to give, sorry, this one is the fourth, I want to give access to the fourth device, so for the to access the printer. So how I can done, so in order to control the accessing or in order to select the particular input so that we can get the output, we will be using some controlling signals. We will be using some controlling signal, and these controlling signals we are going to call it as a select lines. These controlling signals we are going to call it as a select lines. So with the use of these select lines, I can able to select any one of the device so that I will be getting the output so that I can access the printer. One application of this multiplexer, we can see it in one of the simple fundamental where we can see is in the railway stations. Okay, so in this railway stations, what you have, there are so many tracks are there at the railway stations. There are so many tracks are there as the railway station. As the station ends, let's say the station ends over here. So as the stations ends, in most of the cases, there will be only one track will be seen. There will be only one track will be seen. So if the stain whatever they wants to connect, so what they will do is they will use some switches so that they will connect like this. At any instant of time, only one that is a track will be connected to any one of the incoming or outgoing tracks. So we can make use of this mux. So in such a scenarios, are you able to understanding what you mean by multiplexer? Multiplexers are the device which will allow us to select only one input from many inputs so that one input will produce us the output, or you can make use of some accessing some accessories in the output section. Okay, so in general, so what you will be having is, so multiplexer will be having 2 power n input and output will be only one. 2 power n inputs and input will be 2 power n input will be there and output will be 1. So therefore the mux will be represented in terms of 2 power n into 1. So when I substitute n is equal to 2, what happens? So this is become a 4 is to 1. So we call it as a 4 is to 1 mux. Multiplexer, it is also called as a mux. Okay, so now in order to select these four inputs, right, so I told we will be using a select line. So how many select lines will be there? So there will be for 2 power n is to 1 mux, so there will be n select lines will be there. So depending upon the select line, we will be selecting the input so that the corresponding output you will be getting. So this is a scenario, or these are the applications of the mux, so where we are going to use. Okay, so are you able to understanding what I'm telling? Yes, anyone?
Yes, sir.
Are you able to understanding?
Yes, sir.
Okay.
So,
Yes.
so
So
why we will
generally,
take
yes, Pushkar.
so why we will take a 2 to the power 1 is to 1, sir?
See, generally binary means no. So binary, if you consider binary element, what it will be 0, or it will be in terms of 2. It will be generally having one input. It will be having, see, in terms of 2 power zeros only binary will be acting. So in 2 power 0 means it is 1. So 2 power 1 means it will be 2, and 2 power 2 means it will be 4. So means what in digital system? Okay, so always we represent any given input in terms of 2 power n values. It will be easy for us to do the implementation. So therefore, we will be representing in terms of 2 power n only. Is that clear?
Yes, sir.
Okay, so in order to do the implementation, make it easier. So generally in the binary system, or we call it as in a digital system, so always we go for a 2 power n. Okay, so you need to remember only this much. What is that? Mux is an electronic device which will be having 2 power n inputs and produces only one output. So in order to control the inputs, so we will be using a select lines. So the number of select line for the 2 power n is to 1 mux is nothing but n. So depending upon the select line what you are going to give, so that the input will be selected. So for in this case you can see here, so in this case, so how the select line will work is that, see when I give, since I know that there are 4 devices are there, so I need to select any one of them. So how I can give a input to this select line is, so now you can see here, so if I give a select line, so 0 0, so let's say it is S1 and S2. Okay, so if I give an input is equal to 0 0 means I will select a device 1. So if I select line is 0 0 means I will be selecting the first device. Next, if it is 0 1, so I will select the second device. I will select the second device. If the input or if the select line is 1 0, I will select the third device. If the input is 1 1, then I will select the fourth device. Okay, so this is the how you can able to select the inputs. So from many inputs are there, and how you can produce the output as a 1. Okay, so in your textbook or in your syllabus they have not given for 4:1 mux, so they have given a 8:1 mux. So if you have a 8:1 mux means what are the inputs will be having, how many inputs you will be having, how many inputs you will be having?
8, sir.
Yes, 2 power n. So means nothing but 2 power n is equal to 8 is there. So means what? 8 inputs will be there and you'll be having only one output, that is nothing but y. Okay, so it is nothing but 2 power 8 means 8:1. Now what is the value of this n?
3, sir.
Yes,
3,
very
sir.
good. 3 means what? You'll be having a 3 select line. You'll be having a 3 select line. See this 3 select line we can give any name. So sometimes they may give you S0, S1, S2. So they may give you like this or they may give you like that A, B, C. Okay. So and these input terminal we will be representing in terms of data inputs. So it is nothing but D0, D1, D2 like that we will be representing. Okay. So just wait a minute. So we will be representing D0. Just wait a minute. Okay, so this will be D0, this will be D1, this will be D2, this will be D3, this will be D4, D5, okay, and D6 and D7. Okay, so now if I select if I give, so let's say now let's say which device will be selected. So if I give 0 0 1, which device will be selected? Can anybody tell me?
C device, sir.
Which device? 0 0 1.
Sir, D2.
Yes, okay, tell me for 0 0 0,
Sir, D0.
for 0 0 1,
D2.
D1 will be selected. D0 you have said 0 0 0, and for 0 0 1 the next device what you have, so that will be D1, right? So D1 will be selected. Is that clear? So like this will goes on. So like 0 1 0, next, so 0 1 0 means D2 will be selected. Next 0 1 1, so D3 will be selected. The last device will 0 1 1 1 1 means D7 will be selected. And you should not confuse. See, D0 may be any value. It may be 0, it may be 1, but we are making sure that your output will be the corresponding input. We are not spelling it is 0 or 1. We are telling the output will be either it is D0, output will be D1, or it may be D3. This D0 may take 0 and 1. We don't know that value. Okay, if the D0 is 0 means you'll be y is equal to 0 you'll be getting. If D0 is 1 means you'll be getting 1. So what we are doing here in mux is we are selecting the input line, not 0 and 1. Depending upon the input what it has, so based upon that you will be getting the output. Did you understood this one? Did you understood this one?
Yes, sir.
Yes, sir.
Okay. So I request everyone, please make a note of this this diagram. Okay, so here you see they have written a diagram over here. See how they have written. See, if you want to select D naught, what is the condition? It should be A, B, C. What is it? Is A bar, B bar, and C bar. Okay. Now whatever the input you want to feed, right? You want to feed it. So that is why they have taken here. So this is A bar. Okay. And this is B bar, and this is C bar, and this is D naught input what you are giving, and this you are giving to a AND gate. Okay, so now depending upon, see, when A bar, B bar, C bar, see when it is 0 0 0, so it will be 1 1 1. So depending upon the D naught value, you will be getting a output F. Depending upon the one value, you will be getting the output F. Similarly, when 0 1 0, so 0 1 0 means you will be getting D2. So 0 1 0 means what? A bar, A, C bar. Okay, similarly, let's say D5. So D5 means A, B bar, C. Okay, so for that you need to associate a D terminal. So that is what they are doing it over here, and all are NAND gate over here, and we are doing the OR symbol. Why we are doing the OR symbol means because any one of the output we may get it. So therefore we are combine this to a OR gate so that you will be getting a output. Okay, so this is how your multiplexer will work. You please make a note of this circuit, this 8:1 multiplexer, and this table, and even this circuit diagram. Okay, so generally it will be 2 power n is to 1. Generally it will be 2 power n. Generally it will be 2 power n is to n, and select line will be n. So is to 1, and generally select line will be n. Please make a note of it fast. You know, right? You understood, right? How I am writing this diagram? Is anyone? Yes? No? Others are able to understanding this multiplexer? Yes, Swaroop is here. Swaroop, Pranava, Swaroop.
Yes, sir.
Are able to understanding Swaroop?
Yes. Yes.
Please make a note of this diagram. Yes, Nivedita is here. Nivedita N.
Yes, sir.
Are able to understanding Nivedita?
Yes, sir.
Okay. Please make a note of this. Quickly, we will move to the next one.
Excuse me, sir.
Yes.
So can you please once again tell about the logic gates, how we have constructed that?
Here, let's consider first one. So when you get output is equal to D naught, this condition. What is this? A bar, B bar, C bar. So therefore, for this, I will be applying A bar, B bar, C bar. Okay. Along with that, I need to feed the D naught. Depending upon, see this anyway, I have make it 1 1 1. Okay, so now D naught what it will take? Either it can take 0 or 1. Okay, so therefore what I am doing is I am feeding this D naught to AND gate. So depending upon the value of this D naught, your output will be 1 or 0. So if it is 0 means output will be 0. If it is 1 means output will be 1. Why? Because the remaining all are high. A bar, B bar, C bar. What is that value? 1 1 1 1. So depending upon the D naught value, if D naught is, if it is taking 0 means it will be 0. If it is taking 1 means it will be 1. So therefore, in general, I am writing as a D naught. First AND gate. Second AND gate, you see, if I want to take D1 as the output. So what is the condition? Select line what I should give? A bar, B bar, C. So therefore, I am giving A bar, B bar, and C I am giving for this AND gate. Okay, so now again I need to give the D1, right? So D1 I need to pass this to output. So therefore I am passing this D1. So depending upon the D1 value, if D1 is 0 means, so 0 will be transmitted. If D1 is equal to 1 means 1 will be transmitted, because we know that and means all ones has to be there. Okay, so anyway, all these are ones is already there, 3 pins. The remaining pin is depending upon the D1 value. Okay, so and like this, I am summing all the D1, D2, D3 output I am giving to F. Since we know that since all devices will not be active at any instant of time, only one device will be acting. So therefore, the OR expression will be feasible to implement this circuit diagram.
Okay, sir. Got it.
Ah. If you just write A bar, B bar, C bar for the first AND gate, you will not get a required output. See here, if you do not include this D naught means, so what you'll be getting? It is A bar, C bar, B bar you'll be getting. So what is the output is? Output is got it 1. You're not supposed to get output is equal to 1. What you are supposed, you need to select the value of this D naught. So therefore, you need to give D naught. You need to get output as D naught. So therefore, in general, I'm giving one pin as a D naught. So this D naught, either it can take 0 or 1. So if you take it is 0 means the output will be 0. If it takes 1 means then the output will be 1. Is that over?
Yes, sir.
Shall we go for the next one? Shall we go for the next one?
Yes, sir.
The next one we call it as a decoder. The next one we call it as a decoder. So similarly, the multiplexer, so what it has done is the multiplexer, you have a many to one. So now what you have is, so we have one digital circuit. So what it produces output is, so if you have a n input pins, if you have a n input pin means it produces a 2 power n output. It produces a 2 power n outputs. Okay, so such a circuit we call it as a decoder. Okay, so if you have a n input means, so from these n input pins we can able to create 2 power n output. So such a circuit we call it as a decoder. So when you do the encryption and decryption algorithm, or when you want to do the data transmission in digital system, or any, it may be video or it may be audio data transmission, if you want to transmit from one place to another place, so we will be using one operation called as a encoding operation at the transmitter side. Okay, so encoding means compressing the data, or it is precising the data or precising the information, we call it as a encoding. Decoding means again it is getting back to the original one. So in the transmitter side, what you have done is you have precise the given size. Let's say, oh, I should not tell like this. So just for the explanation, I'm telling like this. So let's say you have a 1 MB of data. So this 1 MB of data, I have used some mechanism such that I have converted them into uh, 50. Let 1 MB have taken, right? So I have converted into 3 KB of data. That we call it as an encoder. So now this data I will be transmitting from the transmitter. At the receiver end, what I should do is I should get the original data. So now what I should do is, so this 3 KB data, I should convert it into 1 MB of data. So that will be done by the decoder. So something like we can give an explanation for this decoder. Okay, so generally this decoder will be having a n inputs and you'll be having a 2 power n outputs. So means the coded information, we are going to get back the original information through the use of this decoder. Okay, and there will be no select line in this decoder as it was there in the multiplexer, like so here there will be no select line. So depending upon the input value, so let's say ABC is the 3 input, right? So if it is 0 0 0 means, so the first output will be selected. If ABC is 0 0 0 1 means the next output will selected. If it is 0 1 0 means the next output will be selected. So depending upon the input values, we are going to use a output selection we will be considering. Are you able to understanding? Yes, any doubts? Okay, I request all the students, you please make a note of this diagram. Decoder, see explanation and all anyway I will be giving, and this there is no need for you to take this theory part, since I will be uploading these notes in the MS Teams, just so you can download it, and however you want to create your own notes, you can create your notes. Okay, but I want you to know, write something so that it will be remembering for you. So whatever the discussion we will do it in class, no, so that will last longer for the in time. Are you able to understanding this one, decoder? Is Pushkar?
Yes.
Yes. Prajwal?
Yes, sir.
Okay. Shashireka is here. Shashireka?
Yes, sir.
Are you able to understanding Shashireka?
Yes, sir.
Okay. So this we call it as a decoder. Okay. And the truth table. So you can see it over here. So this is a truth table. Okay. So now you can see here how we have written this truth table is. So when ABC is equal to 0, 0. So the first D naught will be selected, right? So therefore your D naught will be on. So all the remaining output will be 0, 0, 0. Next, when ABC is equal to 0, 0, 1, so your D1 will be selected, all other remaining output will be 0. Similarly, when 0, 1, 0 is there, so means what? 0, 1, 0 means second. So therefore you will be getting a second device. So when 0, 1, 1 means third device, so you'll be getting a third device is active. Fourth device is active. So fifth device is active. So sixth device is active. Finally, the last device is active. Okay. You please make a note of this truth table. So decoder means n to 2 power n. Multiplexer is 2 power n to 1. Is it over this truth table? Have you noted down?
No, sir.
Writing, sir.
Please write it down. Be fast, because we are lack of time is there with me. See, if I should have taken means, if it have got more classes means still better, we should have done it. But it's okay. Whatever the available time is there, so we will use it in an optimum way. See, you have a third hour is free, right?
Yes, sir.
Yes, please, I will be taking the third hour. Please don't mind, because I need to cover the syllabus. So I will be taking the third hour. I will talk with who is taking fourth hour for you today's.
Some mechanic, Naveen HS, sir.
Naveen sir is taking. Okay, I will talk with Naveen sir. If Naveen sir permit me to take fourth hour, and if he is ready to take third hour means, then I will talk with. If I need to take the third hour means, then I will put a message to you. Okay. So I request all the students, you please join for the third hour. If I put a message, you attend it, or else you leave it. Is it over? Okay. So take down this diagram. So the same diagram we have used. Only the thing is a slight change. See, for a D naught, what you need to select when D naught will be 1. So when it is A bar, B bar, C bar. So that is why we have written. See here, A bar, B bar, C bar. It is A bar, B bar, C bar. Okay. Similarly, D1 is A bar, B bar, C. D2 is A bar B B C bar. D3 is A bar B C. D4 is A B bar C. Okay, so based upon that we have written this diagram. Please make a note of this. It is called as a 3:8 decoder. So it is nothing but n:2 power n. See, generally n will be an integer number. It is a whole number. Is it over? Is it over? Yes. Shall we go for the next one?
Yes, sir.
Okay.
Yes, sir.
Okay. So now we finished this combinational circuit. Okay, and we go for the next type of sequence circuits. We call it as a sequential circuit. Okay, so before that, let us try to understand what is this difference between the combinational and circuits and sequential circuit. So still now whatever, see, that is why we have highlighted over here. So you can see here, still now whatever we have discussed, that is nothing but the circuits. So it may be an logic gates, it may be an it may be an XOR gate, or it may be an full adder, half adder, it may be multiplexer or demultiplexer. So the output depends only on the external inputs at any instant of time. Okay, so let's say if you take an AND gate. So if you take an AND gate, what is this? So y is nothing but A into B. So y is nothing but, so if this is A and this is B means, so y will be your A into B. So now what? See, if depending upon this A value, so your output will be changing. So if A changes means y will change. If B changes means y will change. Okay, so depending upon the inputs, so your output is changing. So that we can say that the output depends only on this inputs of the given what you are giving for the any logic circuits. Okay, so such as circuits we call it as a combinational circuits. Okay, so where the output depends only on the present inputs of the given signal means, then we call it as a such as circuits as a combinational circuits. If the output depends on the current inputs and also some previous inputs means, then such as circuits we call it as a sequential circuit. Okay, so it does not only depends upon this A and B, it should depend upon what was the previous value of this A, what was the previous value of B. Depending upon that, if you are getting the output means, then such a circuit we call it as a sequential circuit. So that is the one difference. Second difference, so the combinational circuit does not have any memory. The combinational circuit does not have a memory, whereas the sequential circuit will have a memory. So means what? We can store the data. So if let's say I want to store the logic 1. So I can store the logic 1 in this circuits. So unless and until the value will changes, or unless and until some other input signal changes, so the value will, whatever you feed for such a circuit, it remain in that state only. So therefore we call it as a sequential circuits are having memory. Okay, and now you can see, yes, so just simple diagram what we have represented, the combinational circuit and a sequential circuit. So now you can see here in the combination circuit, so there is no feedback is there. So output and input, there is no interconnection of output and input. But whereas you can see here in the sequential circuit, the combination circuit, you can see here, so the output of this combination circuit, you are giving back to the input section. So means what? There is a feedback is there from output to input in the sequential circuit. There is no feedback is there in the combinational circuit. Okay, and then the last one is, so no time constraints on input and output changes. See, we are not giving any external input signal for the timing signals, but whereas in the sequential circuit we will be giving some pulses, and those pulses we call it as a clock pulses. So depending upon the clock pulses, your output will changes. It's not only for the input signals. If input signal changes, your output will be changes in the combination circuit. But where in the case of sequential circuit, along with the input signal, you will be having some clock signals also. So when the clock signals will changes, so then only your output will changes. So therefore there is a timing constraint is there between the inputs and outputs in the sequential circuits. Okay, so these are the differences between the combinational circuits and the sequential circuits. Okay, so quickly you please make a note of these differences. See, whatever we have studied, it is all about a sequential circuit. Now we are moving from combinational circuit to sequential circuit. So before we go for actually what is this sequential circuit, so it is necessary for us to know what is the difference between combinational circuit and a sequential circuit. So since it is not possible for us to store the value from the combination circuit, so we are going for, or we are shifting from combinational circuit to sequential circuits. Is that clear?
Yes, sir.
Okay. Is it over? Is it over?
So 1 minute.
Please take. Shall we go for the next one? Yes? No? Yes, Nitin, is that over? Nitin, MS, please do it fast.
Sir, over, sir.
Okay. Okay, so next, so be attentive. So we will be using a very important concept in your logic design subject or in the basic electronic subject. So that we call it as a flip-flops or we call it as a latches. Okay. So what do you mean by flip-flops or latches? These are latches or flip-flops are nothing but, so these are the electronic devices or digital devices which we are going to use to store the values. So which we are going to use to store the values. So it is a, we also call it as a 1-bit memory elements. So if you want to store any one value or zero value means, then we will be using it is called as a flip-flops or a latches. So there is a slight difference between latches and flip-flops. So quickly what we will do is, so we will try to understand the first sequential circuit, we call it as a SR latch, and how this operates and what is the things we need to understand this SR latch we will be seeing. So I request once again all the students, you please be attentive over here, because if you understand this SR latch, the remaining thing is a continuation version of this SR latch. So I request all the students, you please be attentive. Okay, so this SR latch we will be implementing through the use of NOR gate. This SR latch we will be implementing through the use of NOR gate. So you can see here, so the given circuit diagram. So the given circuit diagram we call it as a SR latch. The given circuit call it as a SR latch diagram. Okay, so you can see what it is SR latch. So it has a two inputs, one we call it as a S and one more is called as a R, and it has a two outputs. So one we call it as a Q bar and one more we call it as a, sorry, one we call it as a Q and one more we call it as a Q bar. And in the sequential circuits, so you should remember is that always Q and Q bar will be complement to each other. If Q is equal to 0 means then your Q bar will be 1, or if it is 1 means then it will be 0. Okay. So in the sequential circuit, always the output will be having two values. One is a Q and one more is a complement of Q. We will be calling it as a Q bar. Okay. So, and why we are implementing this in terms of NOR gate is because, so since this NOR gate will fall under universal gates, so we can implement this SR latch by using NAND gate also. So for the simplicity, we have taken the NOR gate realization. Okay, and in order to give a highlight what you mean by NOR gate, it is nothing but A plus B, a component of that or complement of that. So the logic truth table for this NOR gate is nothing but when both the inputs are 0, 0, then only you are getting the logic is equal to high. For the remaining cases, your will be 0, 0. Okay, so we are implementing this SR latch. So I request all the students, you please take down this diagram. Okay, so SR latch means it will be having a two input terminal S and R, and it will be having a two output terminal. And you can see here we have a feedback loop over here. So you can see the Q is being given to over here, and the Q bar it is fed back and it has been given to the R gate. Okay. Now we will try to analyze what exactly it is. Okay. Now, so initially we don't know what exactly this values. Okay, so let us try to, we don't know anything on this Q and Q bar. Okay, so we don't know anything on this Q and Q bar. So let us consider some values to this S and R, and based upon the S and R, what you will be getting, this Q and Q bar you will be checking. Okay, are you ready with me? Yes? Shall we go ahead? Okay. Okay. Now you can see here, when S is equal to 1, R is equal to 0, what happens to this circuit? We will check it out. Okay. So now let us try to understand this case when S is equal to 1. When S is equal to 1, what happens? See, irrespective of the other cases, irrespective of this terminal, this always will be equal to 0. Q bar will be always equal to 0. Why? Because we know that in the NOR gate, If any one terminal is 1 means then the output will be 0. So therefore the output of this gate, so let's say it is 2 or it is call it as a 1. So the output of the second gate, it will be 0. So the output of the second gate will be 0. So now what happens? So this Q bar, it is connected back to the gate 1. This Q bar, it is connected back to the gate 1. So now what happens? So the value of this Q bar, what? It is 0. What is S is there? R is there? R is equal to 0. So now 0, 0. What is the operation in the NOR gate? What will be your getting? What is the yes 1? So the Q will be 1. So when S is equal to 1, R is equal to 0. We don't know the value of this Q and Q bar, so we will not make a bother about that. So when you make S is equal to 1 and R is equal to 0, your Q will be 1 and Q bar is equal to 0. Okay, so now we will put some other value and we will see what happens to this diagram. Okay, so what is this Q? Q is nothing but now it is 1 and Q bar is equal to 0. Okay, so now let us try to put S is equal to 0 and R is equal to 0. What happens to this we will see here. Okay, so now when you substitute S is equal to 0, when you substitute S is equal to 0, so what is the output of this logic gate 2?
1.
What is the output of this logic gate 2? Pushkar, it is 1.
Yes, sir.
See Q, what is Q is there? Q is there right here. Output is already there. So what is the output? It is 1. So 0, 1. What is the output? NOR gate.
0.
0, 1 is, yes, it is 0. So 0, 1 is 0. Now what happens? So this 0 will be over here. Now what is the R value? What is R value? Second case.
0, sir.
0. So 0 NOR with 0. What is happens? What will be getting output?
1.
1, sir.
Yes, 1. So now you can see here, this is the beauty of this SR latch. Now, when S is equal to 1, R is equal to 0, you got Q is equal to 1 and Q bar is equal to 0. When you make S is equal to 0 and R is equal to 0, whatever the previous value is there, it has been hold at the moment, or it has been saved the whatever the previous value is there. No, so it has got the values. Okay, so means what? When S is equal to 0 and R is equal to 1, whatever the previous case you got the value, that will be retained. So this concept we call it as a memory. This concept we call it as a memory. Okay, so now what we will do is, so again we will go for this condition only. So okay, now we will check for the next condition. What is the next condition is? So 0, 0 we have checked, 1, 0 we have checked, and we will go for the next condition 0, 1. Okay, so we will go for the condition 1, 0. So now can anybody tell me what is the output of this 1, 0? What is the output of this 1, 0? Is anyone?
So 0, sir.
S is equal to 1 and R will be, sorry, S will be 0 and R will be 1. R will be 1. Okay. Now tell me what is the output of this? What is the Q bar Q output? Q output 0, 1. Yes, it is 0. Next, what about Q bar?
1.
Q bar will be, yes, what is the Q bar?
1.
Q bar will be 1. So now you can see here, when S is equal to 0 and R is equal to 1, you got a Q bar, you got Q is equal to 0 and we got a R is equal to 1. Okay, so now from these three mechanisms, so we can say that when yes, so S corresponds to set value, S corresponds to set value, R corresponds to reset value, or corresponds to reset value. Okay, so now you can see here, when S is equal to 0 and Q is equal to 0, so you got the previous value only, and when s is equal to 1, r is equal to 0, you got sequence wherever s1 is there, right? So you got q is equal to 1. So we call it as a set condition. This is we call. Okay, so when s is equal to 1, r is equal to 0, this condition we call it as a set condition because the data will be set. So therefore we call it as a set condition. Now you consider this condition. What is this condition? When s is equal to 0 and r is equal to 1. R means what? Reset. So reset means we will pull down to 0. So therefore what happens is your q will be 0 and your q bar will be 1. So this we call it as a reset condition. This we call it as a reset condition, whereas this we call it as a set condition. This we call it as a set condition. Now you this one. So what is this condition? So when s is equal to 0, r is equal to 0, it will remain as it is. Whatever may be the output. So whatever the output you had the previous case, so you'll be having the same output. Okay. So this we call it as a no means we call it as a initial state only. We call it as. Okay. So now you consider this case. When s is equal to 1 and r is equal to 1, you consider this case. What happens to this?
Excuse me, sir.
Yes.
Sir, Shrikant sir is waiting for the next class.
Okay. Okay. Then we will wind up it out. Okay. So the remaining thing we will take up in the next class. Okay.
Okay,
So
sir.
thank you. Okay. Thank you, everyone. Thank you all.
Thank you, sir.
Excuse me, sir. Hello.
Yes. Yes, Rasul.
Sir, I didn't understand the input, how you took the input. First you
Input
are
is
taking the
ah.
from where you are taking input.
See, input it is being given by us. Whatever the input you feed, that input will be taken. It's not that you need to give or there is no any logic is there. Since there are two inputs are there, right? So two
Yes, sir.
inputs means you can have a different combination of inputs. So you can see either you can have 0, 0, you can have 0, 1, or you can have 1, 1. So any of these logic you can take it.
Okay, sir.
Okay, so we have taken this 0, 0 condition, we have taken this 0, 1 condition, we have taken this 1, 0 condition, and we have to take this 1, 1. We have not decided this, so we have not seen the behavior of this now.
Okay, sir.
Okay.
Okay, sir.